Hey everyone, Mr. Voikin here. I had a request to go over the triangle question when we are dealing with sides that have radicals, and then just figuring out the unknown side and representing the answer as in simplest form. So this would be a right angle triangle. And like you've been doing for years, we know that Pythagorean's theorem is c squared equals a squared plus b squared. So normally we'd be using numbers like maybe like 23 and 14 here, and that's quite easy to do because there's no radicals to deal with, but because this is a unit on radicals, that's what we're going to be using. Now notice that I have an E, F, and a G right here, but just sort of ignore those right now because we're dealing with that question. So essentially, according to this equation right here, this formula, this is the hypotenuse, which is always going to be C. And then the other two sides can be A and B, or it could be B and A. It doesn't really matter which way you label those two. Okay, as long as this one is the C in that formula. So now what are we trying to solve here? We're trying to solve for B. And if you look at this, it says C equals, what we actually need is B equals something. So we just need to rework this. And to do that, I'm going to, I want to isolate the b. Oh, sorry, this should have a b squared right there. I need to isolate the b. So I'm going to minus a squared and minus a squared from that side, which is going to basically eliminate the a squared from the right. And what I've got here now is c squared minus a squared equals b squared. But again, I'm not trying to calculate b squared, I'm trying to calculate b. So in order to calculate b, I take the square root of b squared, which equals b. And then I take the square root of, well, c squared minus a squared. So that is going to be the formula that I'm going to use. Okay, so I'm going to take this one right here and we'll just move it down a little bit. No, we'll put it back right where it was. I'm going to rewrite it in the other way, saying b equals the square root of c squared minus a squared. So in this case, b equals, well, c is going to be 4 root 6, and I need the square root sign right there. 4 root 6, and don't forget we're going to square that, and I'm going to subtract root 64. Now root 64, hopefully you can recognize that is a perfect square that just equals 8. So a is actually 8, and don't forget we got to square that. So now we have b equals the square root of, well, 4 root 6 is squared, so I need to square the 4 and I need to square the root 6. Well, 4 squared is 16, and root 6 squared, which is root 6 times root 6, is 6. So essentially what we have here is 16 times 6. So 16 times 6 is going to be 96. So this ends up equaling 96. And I know right here that 8 squared is 8 times 8, which is 64. So now essentially what I'm left with is b equals the square root of 96 minus 64. So I have b equals the square root of, well, 96 minus 64 is 32. And now what I want to do is say, can I simplify? So can I take that number, root 32, and pull out a perfect square? Well, what are the perfect squares? They are 4, 9, 16, 25, 36. So it's definitely not going to be 36. That's too high. 25 doesn't work. I know that 9 does not divide into 32 evenly. 4 goes in there, and so does 16. So both of these are perfect squares. So I'm going to pull the largest one that I possibly can out. So what we end up with is b equals the square root of 16 times the square root of 2, and 16 times 2. The square root of 16 times the square root of 2 right here is equal to the square root of 32. So I know that the square root of 16 is 4, and square root 2 I cannot simplify anymore. So my answer is b equals 4 square root 2. So I hope that helps, and let me know if you have any other problems.